Can you hear me? Okay. My wife and I, for the last year and a half, have lived in a wonderful senior citizen complex. It's one of those privileges that some of us have. It's been great. And one of the things they do, they start every program. If it says 4 o'clock, they start at 4 on the dot. And no program lasts more than an hour. And they cut people off at 5 o'clock, and it's over because everybody wants to eat. But sometimes the discipline of that. So we will do that also. We will end at 10:15. So if you're in a long line of questionnaires and you see, go back and sit down. But we're really lucky. The last couple of years, we made an alliance with Mark Wentzler and the Chautauqua Lake Initiative. And it's been so good that it helps us find speakers. It helps us build a coalition on the grounds and in the off season on using science to help make our lives better. And so today, J.D. Stillwater, who is an ambassador for doing that, is going to speak to us. And here he is.
Good morning. Sounds like my mic is not quite connected yet. We'll give it a second. There we go. Thank you very much. I'm honored that you've joined us on this gorgeous, gorgeous morning that is slowly working itself into a warmer afternoon. So I appreciate you being here. Take a breath with me, will you? And just let the cares of the day dissipate a little bit. Feel yourself settle into your body as you listen to a few words from Ralph Waldo Emerson, who wrote, "Within us is the soul of the whole, the wise silence, the universal beauty, to which every part and particle is equally related, the eternal one. When it breaks through our intellect, it is genius. When it breathes through our will, it is virtue. And when it flows through our affections, it is love." Just a reminder to silence your cell phones, and also I'll make sure to leave time for questions at the end, so save them up. My spouse, Ann, wave your hand back there, Ann, that's Ann. Ann and I are low-budget travelers, and when our kids were small, we wanted to take them to visit Carlsbad Caverns as part of a cross-country family adventure. Well, the only accommodations near the park were way out of our price range, but we'd heard that it is legal to camp anywhere on land that's owned by the Federal Bureau of Land Management. And our AAA map, remember those? Our map showed this huge expanse of desert right across the highway from the park, marked BLM. So that was perfect for us. We drove out a sort of rugged dirt track and pitched our tent on the dusty hardpan there. And we made and ate supper, but before going to bed, I realized that I needed to use the restroom. Number 2. Well, the closest restroom was over the horizon from where we were. But we are veteran campers, enough to know that here in the eastern woodlands, it's proper to bury one's bodily waste at least 6 inches deep. But there, in the high desert, proper disposal involves leaving it to dry in the sun. So I strolled some distance away from our campsite before taking care of business while enjoying the crystal clear star field above my head. And at this point, you may be thinking that this story involves a painful encounter with a cactus. But no, there were plenty of prickly plants around. But this story's magic begins the next morning. As we packed up in the bright morning sun, we saw something that you cannot see here in Pennsylvania or New York or any of these eastern coastal states. At different times, 4 large beetles came through our camping area, each one rolling a dusty little marble along the ground, following surprisingly straight trajectories. And those tracks exhibited a strange kind of pattern. They seemed to radiate out from a single point some ways off. You've guessed what point. We were mystified, so we followed their paths in reverse, and we encountered dozens of similar beetles racing out in all directions from the now completely bare spot where I had squatted the night before. How did they find it? Where were they going? It was astounding and kind of unnerving, and it obviously made a lasting impression on me. Well, I now know that dung beetles need those precious brown marbles to feed and nurture their own children. And in the desert, they often only get one shot at it, if they get even one. Now, this happened long before I started thinking in earnest about science and unity and oneness. But it was an intimate and kind of a visceral lesson in the ways that I am connected to the world around me, especially the living world. Now, I hate to disappoint, but this is not a talk about dung beetles. It is about the science of oneness. And you might expect science to be kind of a big party pooper when it comes to unity and oneness, a kind of humbug know-it-all who ridicules all that kumbaya stuff in favor of cold, hard reality. Well, play along with me here, and let's just see what science has to say about unity and reality. Maybe we should start at the beginning of time. According to the best evidence science has to work with so far, our universe began as a singularity. What an interesting name, given my topic of oneness. There's a reason it's called that. The singularity at the beginning of time contained the entire universe, but compacted infinitely dense, so that it had no volume, no size at all. Both of these definitions apply there at the beginning of time. The cosmos was indivisibly singular, and it was infinitely small and infinitely dense. Children's author Carol Martignaccio calls it the everything seed, the seed that grew into everything. Nobody knows what happened before the beginning of time, but all the evidence we have now says that at the beginning of time, that tiny speck rapidly expanded or inflated, creating space and time as it did so. So everything in the universe, from this talk this morning to interstellar dust in the most distant galaxies out there, it's all traceable back to that one single thing at the beginning of time. And I want to emphasize that the rest of our story is still one single thing, evolving through a process of diversifying. At the beginning of time, there was only energy. No atoms, no matter, no mass, no space even. No solids, liquids, or gases, nothing that we would call a thing. There was just pure energy in the form of extremely bright light. Now, matter and energy are like nouns and verbs. Matter is stuff, things, objects. Energy is movement, action, ability, potential. How did the universe make all this stuff if all it had to work with was energy? In the sentence, girls are running, everyone knows girls can run, right? But they can't become running. Girls are, running happens. As a noun, she can do running, but she can't become running, and the verb running cannot become a girl. Common sense, right? Stay with me now. Along comes this guy who showed us that the verbs of energy can become the nouns of matter. Running can become girls. Crazy, but true. At extreme energy densities, in other words, when it's hot enough, matter can condense out of extremely bright light. And in the first moments after time began, particles that would later form atoms of hydrogen and helium condensed out of nothing more substantial than bright light. And this isn't somebody's fantasy or daydream. This is what physical evidence tells us happened. To me, this is a kind of revelation, and I use that word deliberately. Yes, it's often associated with religion, but it's the right word in this case. Carl Sagan famously said, "If you wish to make an apple pie from scratch, you must first invent the universe." That's brilliant. We don't know where that initial singularity came from, or what it would even mean for something to happen before the beginning of time. But we do know that everything in this universe, everything that's an object, as well as all the things that are energies, or events, or that are still mysterious, like dark matter, they all have a common origin, a shared genesis in the energy of the Big Bang singularity. You may recall way back in 1969, Joni Mitchell sang, "We are stardust. We are billion-year-old carbon." Well, it's literally true. The early universe only had particles that would later cool enough to form atoms of hydrogen and helium. But that's it. You cannot make an apple pie from scratch if all you have in the pantry is hydrogen and helium, right? Where did all this other stuff come from? Well, there is one thing you can make from atoms of hydrogen and helium: stars. But stars didn't exist yet there in the beginning. The universe only had this diffuse gas of hydrogen and helium, all spread out in space. But over time, a long time, gravity gathered those atoms into the first generation of stars. And that was convenient for us because making heavier atoms, like we're made of, making heavier atoms from light ones requires really high temperatures, like those inside the sun, which, as you know, is a star. And that's what stars do. They smash atomic nuclei together at such high temperatures that instead of repelling each other like normal, they stick. What is he talking about? Well, here's another way to imagine this. Let's say we fire two bouncy balls from cannons so that they collide head on. Wouldn't that be fun? That's the kind of thing I would actually try. At any speed I can even imagine, they're just going to bounce off each other, right? And so do the nuclei of atoms, usually. But imagine if we could fire those bouncy balls at such a high speed that the rubber of the balls would actually melt when they hit, so they end up sticking together. That's a little bit like the nuclear fusion process in stars, where temperatures, speeds, are high enough to smash together particles that usually repel each other into ever larger clumps, to turn simple atoms like hydrogen and helium into heavier elements like lithium, carbon, oxygen, and so on. By the way, fusion also happens in nuclear bombs, like most of those in our nuclear arsenal today. And one of the goals, as you probably know, of nuclear energy research is controlled fusion, so that instead of an explosion or a star, we can make electricity from this process. But normal stars can't make anything heavier than iron. And any atoms they do build are just going to sit there inside the star forever. So none of this planet stuff came from normal stars. But there are some stars, supermassive stars, that kind of live fast and die young. And they go out with a bang, called a supernova explosion. And in the moments of that explosion, temperatures are so high that all the other natural elements can be formed, even really heavy ones like lead and uranium and gold. But then those fusion products get exploded out, dispersed as precious hot dust that gravity, again, can slowly collect into new solar systems, but this time with all that dust available to make planets. And we know that on at least one of those planets, life happened and evolved into the living Earth that we enjoy today. I know, that was a very fast trip through nearly 14 billion years of history. But my point here is that the seeds of you and me, the seeds of our bodies, were present there at the dawn of time. And we are descended from stars, just like those we see in the night sky. Stars are in our family. We're not only connected to events in the early universe, we are those events, still occurring, still unfolding. We are still one thing, with all our diversity, with all the different galaxies, stars, and planets, and of course, a tremendous diversity of living things on Earth. There's arguably only one universe-sized event happening here. A few years after that fateful camping trip with the dung beetles, I was teaching high school physics, and I noticed something about gravity. Now, this is high school, so we're talking Newton's law of gravitation, which you can use to calculate the force of gravitational attraction between any two objects. And if algebra is not your forte, just close your eyes. You don't need this. Einstein changed how we conceive of gravity, but Newton's equation still works for most things. And it reveals that gravity is not just something planets do. There is a force of gravitational attraction between any two objects with mass. And you can calculate it if you know their masses and the distance between them. And it's weak. Gravity is actually the weakest force in the universe. So you need something the size of a planet to really feel it. Anyhow, I would always make up my own homework problems because I wanted students to personalize the material. And I would make up questions like, what is the gravitational attraction between your body and that kid you have a crush on across the classroom or whatever? And what if that person is standing on Pluto now? And I'd give them the masses and the distances, and it was a little more fun. Well, at some point while composing these homework problems, it dawned on me that the answer will never be 0. It can be really, really small. No matter how small the objects are or how far apart, there is always some little force of attraction. And this was a eureka moment for me. There are invisible threads of gravitational connection radiating out from my body, connecting me gravitationally with everything in the universe, from zebras in Zimbabwe to asteroids in Alpha Centauri. Uncountable threads of connection that shift and flex every time I move. The mass in my body helps hold the Milky Way galaxy together. Yours too. I felt like I had stumbled on something profound. Another one came when I taught biology and earth science in the same semester. You may remember that photosynthesis allows plants to make themselves out of carbon dioxide and water, storing the energy of sunlight in the chemical bonds of sugars. Well, in turn, we make ourselves out of plants, either directly or indirectly. So ultimately, our bodies are made of CO2 and water. So I want to take a closer look at those two ingredients. Here's a diagram of the water cycle, and you've probably seen something like this before. You know that water evaporates from the ocean and drifts over the land, and then it rains or snows back down, and then runs downhill to the sea. But there's something missing here, and it's missing from almost all the water cycle diagrams I've ever seen. It's us. One of the things some of the water does as it goes around its cycle is be you. Water molecules are so small and so numerous, and they cycle around the earth so constantly that every cup of beverage you swallow contains at least 150 million water molecules that were once inside the body of your faith's founding prophet, whether that's Abraham, Jesus, Muhammad, Buddha, Arjuna, Confucius, Lao Tzu, Spinoza, or Aristotle. Talk about holy water. The longer each of those famous people lived, the more millions of molecules are in your body right now that were also once in theirs. And you contain water from all of them. Every cup of water, juice, soda, coffee, every cup contains water molecules that were once part of every creature that ever lived more than a few decades ago. We drink this holy water, and it comes alive inside us, becomes part of the living system of our bodies. Personally, I think that makes each of us holy too, in a way. The carbon cycle is similar, except that as carbon goes around its cycle, it spends time as seashells, coal and petroleum, limestone, concrete, all these carbonate compounds. Also, some time as living processes like our bodies. Some of the carbon atoms posing as you right now were gasoline in my car last winter. You can calculate these things. Same is true of the nitrogen cycle, the oxygen cycle, the saline cycle, all these earthly cycles of the atoms and molecules that make up our bodies. You ever wondered what it would be like to be an atom going around one of those cycles? Well, I have. I'm a little weird. And that pondering for me came out as a poem called An Atom's Life, and I want to share just an excerpt. If carbon could choose, would it be a diamond or a daughter? There are entire planets of solid diamond. They do not smell like macaroni or squeal with laughter, swinging between strong hands, strolling through gentle breezes. They do not cuddle under downy quilts for communion, cannot dance under hot, pregnant skies, their breath and sweat mingling into iron-rich ancestral soils. Yes, if iron could choose, there would be no asteroids. They would fall in swarms, rusty storms of shooting stars, each atom straining with aspiration to become blood-red hemoglobin, light-sensing retinol, muscular myoglobin of living motion, each coveting a chance to live, to bleed, to see the stars, and to reach for them in person. So your body is made of the lucky few zillions of atoms that get to be alive in person as you. We are part of those interconnected natural cycles that, kids study these things in science class, and we teach them like they're out there somewhere, but they're also right here. We are in those cycles, and they are in us. Every year, about 98% of the atoms in your body get exchanged for new ones. 98%. So a human body is like a standing wave on a river. Matter moves through us, becomes us briefly, and then moves on to become something else. Our bodies aren't really things, they're flows. Or maybe more accurately, our bodies are complex patterns in the flow of matter. And the flow is completely interconnected with the Earth as a whole, because the atmosphere, the hydrosphere, and the lithosphere, these are all interconnected systems. We are Earth. Some days I feel like I must have been abandoned here by aliens. But, even if I were, within a year or so, my body would be entirely made up of the water, air, and minerals of Earth. I am Earth. We are Earth. And I regret to tell you that it's not just inanimate matter that cycles through us. Other living things flow through us too and become us temporarily as they do. Mostly I'm talking about bacteria here, although fungi, viruses, even arthropods make up our bodies as well. On and inside us, bacterial cells actually outnumber the human cells. There are thousands of species, trillions of bacterial cells, all cooperating and competing with each other and with us all the time. They digest our food, they protect our inner and outer linings. And in the last few years, microbiologists have found that the species living on and in us influence when we're hungry and thirsty, our food preferences, our weight, and even our emotions. So, is it me who loves cheesecake or we? And the human cells in our bodies each contain dozens of mitochondria, often called the powerhouse of the cell. And these mitochondria turn sugars into energy so that we can do things. This is the opposite of photosynthesis. Mitochondria break sugars back down into carbon dioxide and water, releasing the solar energy from sunlight back out into our cells, available to keep us warm or move our muscles, anything we need energy for. You see how this connects with both the water cycle and the carbon cycle? Well, we now know that mitochondria are actually the descendants of ancient bacteria still operating cooperatively inside our much larger human cells. And mitochondria have their own DNA, separate from the human DNA in your chromosomes. And we use that DNA to discover that you got all your mitochondria from your mother, and she got them from her mother, and so on, matrilineally, because the mitochondria in sperm don't survive fertilization. Paleogeneticists have been able to use the well-established mutation rate of mitochondrial DNA to determine that every human being alive today is a descendant of one woman who lived in Eastern Africa about 200,000 years ago. She's referred to as mitochondrial Eve, the most recent common female ancestor of all of us. This is National Geographic's map of how we migrated to every other continent since then. Similarly, if you have a Y chromosome, you got it from your father. And like all chromosomes, the Y chromosome accumulates small mutations that can get passed on from generation to generation. And we can trace those small differences back through families to find common ancestors. And when we do that, they all converge on an unknown man who's called Y chromosomal Adam, the great-great-grandfather of everyone alive on the planet today, at least everyone who has a Y chromosome. No surprise, migration maps from mitochondrial DNA and those from the Y chromosomal, they're called SNPs. Anyway, those maps match up with each other and also with anthropological evidence. And I need to emphasize here that mitochondrial Eve and Y chromosomal Adam were not a couple. Don't let the names Adam and Eve fool you into thinking these two are the ones mentioned in Genesis. These two almost certainly lived thousands of years and hundreds of miles apart. What we're sure of is that they were black people. They were African people living in Africa. They had parents and siblings and cousins. They are just the most recent ancestors of ours whose mitochondria and Y chromosomes are still around, present in the bodies of people alive today. Consider the implications. This means every human being alive today, regardless of race, gender, ethnicity, they all have the same great-great-great-grandparents that you do. So think about your neighbors, and people you work with, people on the other side of the planet, people we're at war with. These are your cousins. There's only one family of people on this planet. Similar genetic analyses and lots of evidence from many angles of inquiry tells us that every living thing on the planet is a blood relative too, even the ones that don't have blood. We share half our genes with bananas. Bananas are your cousins, and they're delicious. All living things are related. We are part of a single, unbroken family tree stretching back nearly 4 billion years. Researcher Dr. Daniel Wildcat says, we live among relatives, not resources. We live among relatives, not resources. You may have heard of the butterfly effect, which came out of complexity theory, especially as it applies to weather forecasting. And the idea is that complex systems like the weather have so many factors involved that they are highly sensitive to small changes that can accumulate over time. So for example, a change as small as a butterfly flapping its wings in Washington can make enough of a difference to cause or prevent a typhoon in Tokyo a month or two later. Well, that means every time you breathe, you change the state of the atmosphere enough to totally rearrange the weather sometime later, because each air molecule bumps into the ones around it, causing them to move and so on. But then the atmosphere is thermodynamically connected to everything. Stock prices, war outcomes, the biosphere, the hydrosphere, mountains, glaciers, everything on Earth. So everything affects everything else sooner or later. And that same butterfly effect sensitivity is built into many complex systems, and all of those systems are connected. I mentioned gravity earlier. No more equations, I promise. But the orbits of planets, which are governed by gravity, have this same kind of complexity because they all experience little gravitational tugs from one another and from the sun, as well as from smaller objects that are the gravitational analogs of butterfly wings for weather. And all of them are in constant motion. The researchers at NASA who modeled those orbits told National Geographic a few years ago that a change as small as moving a pencil across a desk on Earth is enough to shift Jupiter halfway around its orbit a billion years later. Now that's a small change in a very long time, but it's still significant. Your body is about 10,000 times the mass of a pencil. So those invisible threads of gravitational connection, they're not just some fanciful idea. They have gravitas. And there are many more examples of our connection and unity from science. The bottom line here is that we cannot separate ourselves from the cosmos, or more immediately, from the Earth. We are the Earth. The Earth is giving this talk today, and the Earth is sitting in those earthen chairs listening. We and it are us, one thing with many parts. Our attempts to separate ourselves from the Earth, to exploit and commodify its parts, they're kind of like me trying to sell my liver or my heart to buy a bigger house in a nicer neighborhood. It just doesn't work for very long. Earth's whole and healthy systems are essential to my life. So there's only one story, 14 billion years long. And the characters in the story are completely interconnected on every level of existence. But what about the setting? What about space and time? Well, a century ago, that same smart guy showed us that space and time are actually unitive. They appear different to us, but they're actually a single expression of reality, space-time. And here we are about a century later, and one of the hot concepts in particle physics is non-locality. We think of space-time as having a kind of framework or a fabric. Even if it bends and curves, there's a predictability to it, right? Things can be located. And two different locations are different. There's space between them, and that space is real. The separation is real, we think, right? Quantum entanglement calls all of that into question. And evidence is piling up that space-time may be non-local, meaning that maybe location has no meaning. I won't try to explain quantum entanglement in this talk. You're welcome. Except to say that two particles that are entangled seem to communicate with one another over long distances instantaneously, faster than the speed of light. Another way to think of it is that entangled particles become a single object that can be in two places at the same time. And this picture is just for fun. Next, I want to share a figure from a paper published in 2015 in the journal Physical Review Letters with the title, How Space-Time is Built by Quantum Entanglement. Entanglement giving rise to space-time rather than happening in space-time. Well, that same year, science writer George Musser was published in Scientific American, writing, quote, Multiple branches of physics now suggest that at a deeper level, there may be no such thing as place and no such thing as distance, end quote. Non-locality suggests there's only one place here, one location, even after billions of years of cosmic expansion and diversification, as though we are still in a singularity, but somehow diversified. And you know, the name we give this cosmic body of ours offers a clue. One turning, one single event, one song. 750 years ago, long before modern science, the poet Rumi wrote, "You are not a drop in the ocean. You are the entire ocean in a drop." Coming from science means that these revelations offer to bridge cultural and religious divides, because people all over the world, from all kinds of backgrounds, can look at the scientific evidence, experience awe and wonder and connection together. But still, what should I do with this knowledge? What does it mean for a daily life? Well, I think I can start with awareness. When I drink, I can think about how this cup of coffee or juice or whatever contains molecular emissaries from every ocean and from all my ancestors, from every creature that ever lived. When I look up at the night sky, I can see ancient ancestors and life-givers twinkling there and give thanks. When I see a dung beetle cleaning up a mess, I can say, "Hey there, cousin, congratulations on finding a nice nursery, and thanks for your work." As I walk in the woods, I can see relatives rather than resources. I can greet new people like long-lost cousins I'm meeting for the first time. Once aware, I can accept that everything I do affects everything else, no exceptions. I can sit with that for a while, letting both the power and the responsibility of it settle in my heart and my mind. I can affirm, I matter. As long as I'm alive, all those interconnected threads run through me too. Something I'm practicing is to use me less and we more. Kind of like that old bumper sticker, think globally, act locally. I try to think of myself as an expression of the universe, a tiny cell in the body of something vast, ancient, and dependent on me like I'm dependent on each of my own cells. You know, my blood cells and my bone cells are completely different from one another, performing nearly opposite roles in the ecosystem of my body. But I'd be a mess if my blood cells convinced all my bone-headed bone cells to become just like them, right? Unity doesn't mean uniformity. It doesn't mean I shouldn't be active in making the world better. It's good that other people are different from me. And this awareness of universal oneness is hardly new, right? It's a thread that runs through the fabric of every culture and religious tradition in one way or another. What's new is empirical, physical, scientific confirmation of it. Confirmation that transcends accidents of birth, like nation, language, and culture. Here's how the Reverend Dr. Martin Luther King Jr. expressed it in his letter from a Birmingham jail. Quote, "In a real sense, all life is interrelated. All men are caught in an inescapable network of mutuality, tied in a single garment of destiny. Whatever affects one directly affects all indirectly. This is the interrelated structure of reality." End quote. So what science says about unity and oneness is that your life story and my life story and those of dung beetles and germs and worms and rocks and flocks of geese and the moons and the Pleiades and distant galaxies' life stories are all the same story, because there's only one story and there's only one character in the story: we, us, the universe. And I say this not as some kind of religious mystic, but as a hardcore, show me the evidence ambassador for mainstream science. And you know, the 7 and 70th generations of our grandchildren are part of the interconnected web too. What can I do for them today? How will they know that I love them? How can I sing to them across this web of oneness that unites all space and time into a single song? This moment in this talk is that song, still being sung, and each of us sings a unique and essential note in the overall chord. We, us, the universe. One song. What else can I do but resolve to treat everyone and everything I encounter as an essential expression of my largest self? Because it is. Thanks for being here this morning. This was fun for me. What time is it? Whoa. Good on time.
Okay, guys, you know the drill. Come to the microphone and ask a question. It's pretty straightforward.
All people may need to lift it up a little bit.
This isn't so much a question as an observation, and you can treat it as a question if you like. When I was in college, possibly under the influence of illegal substances, I was sitting in a chair in my dorm room, and it occurred to me at the time that I was really no different than that chair, and that if there were such a thing as value, the value was in the assembly and the arrangement of the substances that made up me and made up my chair. And I think that's essentially what you're talking about.
I think you've just given a brilliant definition of emergence. It's a relatively new concept among the sciences, but it's the idea that first of all, the arrangement really matters. And when the arrangement is just so, new properties can emerge that you can't predict from the parts. So for example, you can know a lot about oxygen and hydrogen, and you still can't predict rainbows and snowflakes. Something happens when oxygen and hydrogen come together to make a water molecule, and then there's a broad range of environments that water molecule can be in, and when it's bulk water molecules, uncountable numbers of them, things happen that can't happen with hydrogen and oxygen separate. And a human being, one of the differences between a human being or any living thing and a chair is that just so arrangement in a certain constrained environment that allows new properties to emerge, like your ability to stand at a microphone. A chair can't do that. But you could take all of this stuff right here and put it in a blender and make all kinds of things, dead and alive. These same molecules could make a Great Dane, right? What's different is the arrangement.
Thank you. Your talk's superb.
So conscious thought that you just brilliantly used, is that just a chemical reaction going on in your brain, or is there something deeper there?
If I knew the answer to questions about consciousness, I would be up for a Nobel Prize. Consciousness is a very exciting field. I don't know why. Well, I think people did think of it before, but we didn't have the neurological tools to study what's going on in the brain. And the relationship between the mind and the brain is just a really hot topic right now. One of the problems is we don't have a consistent definition for consciousness. We don't know what it is. There's a kind of recursiveness about conscious minds considering the nature of consciousness. So it's a really hard, they call it the hard problem. It's a really hard problem. And it's really exciting frontier that people are making progress on right now. But I don't have the answer because nobody does. But it's one of the things I love about science is that it's always operating at a frontier. And there's excitement, there's a kind of mystery there, and it's partly what makes life wonderful. I don't believe in a theory of everything. If we ever had a theory of literally everything, it would be the end of science. And how awful would that be? There would be nothing left to get excited about.
I want to thank you for building on Neil deGrasse Tyson's lesson to us last week, that for us to understand science, we need to do it through stories. Yeah. And that stories, everything we really, really understand is through stories. But the hows and the whys are where science works. Right. And that connection between big understanding through stories and little steps through how and why, I don't understand that. How do we merge the how and why of science and the big stories of one song and not get lost?
Well, for me, it's about personalizing it. It really is about taking it to heart. You know, when you walk through the woods, don't see lumber, see cousins, and get to know them. And yeah, I don't have an empirical way of explaining this, but it has to do with opening your heart. I don't mean your physical heart. I mean engaging with the world with a kind of religious sensibility, devotion, reverence, curiosity, love. Loving the world, not just other people, but everything. Recognizing that is an integral part of your being, not lumber or whatever it is that you're engaging with. Engage with it with your whole self. That's the best I can offer. And I'm a rank amateur at it. You know, I grew up in this culture, this Western culture that tends to commodify, tends to separate, tends to think in binaries, very linear kinds of thinking. We have so much to learn from our indigenous older brother and sister cultures.
I guess what you just said sort of changes the question in my mind, and that is, where do the sentiments, the love, the feeling that you just enunciated beautifully, and thank you for your lecture, it was very good. How does that come out of the materialistic universe that you seem to see as your focus?
Well, you have given me an opening that if I walk through it, we could be here for a while. Science is rightfully called materialistic. And science, over the last 5 centuries, has brought us to the point where we now know there are no materials in this universe. Science is reductionistic. It takes things apart, and it looks at the parts, and then it takes those parts apart and looks at those parts, smaller and smaller and smaller. And when we get down to the atomic level and start to take atoms apart, we find energy. There are no things inside of atoms. There are no objects. There are waves and fields and energy that act like objects, but it is still just energy interacting with itself. So I showed a picture of gears when I was talking about cold, hard reality. Reality is not cold, it's not hard, and it's not made of objects. So materialism has brought us to really a kind of mysticism. Our ancestors would absolutely have regarded quantum physics as mystical. But it's also empirical. The math works. The experiments confirm it. So, now I've forgotten your question, but you used the word material and materialism, and you're absolutely right, but we've got to stop thinking of science in Newtonian terms. So, if what you think about science, if your perception of science came from your high school chemistry textbook, let go of that. That's from before the last century. And what we've learned in the last century is that this world is not Newtonian. It's not made of objects that interact. The whole thing is just energy interacting with itself. And we are an astounding expression of that at the macro level.
I guess, does that allow then the probability there's an extrasensory reality?
The question is, does that allow for the possibility of an extrasensory reality? I don't know. I don't know. I'm confident that there are whole fields of science yet to be discovered, but whether they would overlap or match up with what we might have traditionally called more religious perceptions of the world, I'm skeptical, but I can't rule it out.
A question and a comment. The question, with regard to the water cycle, do you have any comments on anticipated impacts of PFAS and microplastics in particular, and how they may interrupt negatively that water cycle? And then I have a brief comment.
I don't think they'll interrupt the water cycle at all, but the impact on living things is already devastating. So, I mean, the water's going to continue going around its cycle. Climate change may have a much bigger impact on the water cycle, as it has been for the last 10,000 years. But over the long run, by which I mean millions or billions of years, the Earth is going to be fine. It just may not include us. But the kinds of chemical pollution you're talking about, we already know. There's I don't know if it's a meme or just what, but I saw this somewhere on social media. You're half the man your father was. And then in this fine print, it says sperm counts are half what they were 2 generations ago. And it's because of microplastics and PFAS and other things like that. So, I mean, we're just doing it to ourselves, but the water cycle is going to keep cycling.
And then my comment briefly is, anyone who thinks that J.D. Stillwater is full of SHIT is not familiar with your dung beetle camping story.
I look around and as I start to get into the story, I can see some faces that are like, where is he going with this? Not sure I want to hear this. Go ahead.
I think you should run for president.
No, thank you.
We need more global thinking in our world, especially today. I happen to be the president of a UU fellowship in Maryland. I'm going to write to you and see if you're available to do a talk.
Grab one of my cards. They're on the table back there.
Thank
Yeah, most of my work is in churches on Sunday mornings, sharing what I think of, but don't put this in the paper, as the gospel of science. I mean, it's a way of knowing that it offers to bring the world's faiths and cultures together in a way that nothing else can. It's a truly global interfaith community that creates all of this knowledge. Empirical, testable, scientific knowledge.
What you're talking about this morning is really Gaia, and I was wondering whether you ever had an opportunity to interact with James Lovelock and Lynn Margulies.
Not in person. I have not met them. I would love to. And I haven't really dug deep into the Gaia hypothesis, but as a general concept, I think it's true. I mean, it kind of relates with emergence. If you think of highly complex systems that take on a kind of life of their own, then it's certainly reasonable to think of the Earth as a kind of organism, and us as cells in its body. But I don't know enough about the details of it to really to embrace it wholeheartedly, or to say, I got a few quibbles, or to reject it. But I don't think I would reject it.
Well, it very much complements what you've been presenting today. And I had one other question, which is, this is a powerful message that you're giving. How do we communicate that with children and get them to start thinking about this at an earlier age?
That's another long tirade that I won't subject you to. I spent 25 years in K-12 classrooms, science classrooms. And the system we have built, it focuses on facts instead of heart. It can't do a good job of personalizing science knowledge. So we have to do a better job with science education. We do. But more testing is not going to help. And paying science teachers adequately. I mean, there are just so many things that need to be overhauled. But kids want this. Kids are full of awe and wonder by nature. We pound it out of them by making them sit in desks for 8 hours a day. I'll stop there. But it's a whole.
want to add, though, that for them to understand their place in the universe,
Yeah.
for us to understand our place in the universe is absolutely essential.
Absolutely.
And this is more than just science class. It's,
Agreed.
is it creating stories for them? Or
Yes.
whatever?
Yes. All of that. Writing books. You have a kid's book, don't you? I do, and actually.
We'll get to that, Alice.
The,
We're going to make this the last question.
Okay.
It is the last one.
A quick question. There's a lot talked about disentangled, whatever they are.
particles, photons.
Particles that are disentangled and that they will be opposites and such at great distances,
Right.
spooky distances.
Yeah.
But no one ever talks about how do you entangle two particles. All this talk is afterward, but what happens? How do they get tangled?
It depends on the kind of particle. So photons can get entangled just with a half-silvered mirror. You take a photon, you shoot it at a mirror that cuts light in half,
Yeah.
and now you've got two photons, and they're entangled,
And they're
because they came from one photon. With larger things like electrons or even protons, neutrons, whole atoms, it's a different process that
But entanglement doesn't happen naturally. We have to create a situation that makes an entangled particle.
No, I think they do get entangled naturally, but I'm not certain. I better not say more, because
Okay.
that's beyond my knowledge.
Your pay grade. Thank you very much. It was a very
welcome.
thought-provoking presentation.
I'm glad.
Thank you, Jay. I'm so glad that we now understand the water cycle better. But there's another cycle. To be able to do this, we pay for ads in the daily. We give a contribution to this wonderful church to let us use this. We give a scholarship every year to a student at the Chautauqua Central School. All of this requires the recycling of your money. And in the back table, there's a basket. Drop something in it. I don't want to hear it jingling, but drop something in it that folds, and we'll be able to do this again and again and again. So thank you, and thank all of you for being here, and we hope to see you next week.
If you decide you want one of my books, donate first, and then come look at the books.